Today's lesson will be on identifying and using constants of proportionality from graphs and tables. This will be page 23 of your notebook, so please make sure you add page 23 to your table of contents. And we're going to start off on the front of the notes where these two pre-written examples are. So first off, remember to put your units. A student made this meme a few years ago about how it feels when you get something wrong because you forgot the units. So on the front of the note sheet, we have this graph. I've written in the y value for the y-axis and the x value for the x-axis. And in the example here, I use the first ordered pair, y over x. So we have 20 over 5, which simplifies to 4 over 1. I could have used any of these other ordered pairs. 60 over 15 is also 4 over 1. 40 over 10 is also 4 over 1. And as we talked about with our vocab yesterday, matchy-matchy, okay? All these ordered pairs are going to result in 4 over 1. So 4 is our y. Y is on the y-axis. That would be our water in liters. And 1 is representing our x, which is the number of containers. Therefore, this represents that there are 4 liters of water per container. Looking at the table example below the graph, we have a field trip to Six Flags Discovery Kingdom. The first is our inputs, which is always x, and the second values are our y, which is the total cost, which is our outputs. So once again, we're going to do y over x. So we have our y value over our x. You could use any of these values to find the constant of proportionality because they will all equal the same amount. I went ahead and wrote what you see on your calculator. 5,405 divided by 230 will be 23.5. What that means, our y value is the total cost. So the field trip costs $23.50. You need to add a 0 because this is money, and it's $23.50 per student because our x is the number of students. So also please make sure you highlight the front of your note sheet. Any of these examples, you could highlight these numbers, where they come from. You could add in that we divided by 230 to get this. So just make sure you're adding something to your notes on the front. Okay, now we're on the inside left of your notes because these are foldable notes. And example 1a is what is the constant of proportionality? So based on the examples on the front, think about how you would find the constant proportionality. Well, we're going to be using our ratio y over x. Remember, the vertical part is the y-axis and the horizontal is the x-axis. So be careful on this one because oftentimes people will say the constant proportionality is 3, but 3 is incorrect because our y value is 4. Here is the y value, here is the y value, and the x value is 12. So here are the 3 ordered pairs. You could use any of them. I tend to choose the smallest one. So in this case, we have y, which is 4 over x, 4 over 12, which simplifies to 1/3. So therefore, the average is 1/3 of a download per website. So I guess this could actually remove the S here. 1/3 of a download per each website. And then in 1b, I'd like you to fill this in for the question. What does 0, 0 represent on this graph? So if we have 0, 0 in this situation, it's going to represent that there are 0 downloads when there are 0 web visits, or after 0 web visits, there are 0 downloads, which does make sense. Don't forget your units when you're describing these, okay? You need to have downloads per website on this one, and you need to have after 0 websites, there are 0 downloads. So on 1C, how many downloads would you expect from 24 web visits? So on this one, you can just use your table. You go to web visits. Here's 24. You go up to what the graph tells us. It crosses here, and therefore, after 24 web visits, there are 8 downloads. And another way to prove it is 24 times our constant proportionality, x times 1/3, 24 times 1/3 will equal 8 because 24 divided by 3 is 8. Now we're on to example 2, which is the bottom left of your note sheet. And 2a says, what is the constant of proportionality? So we have some dots given here on the graph. So we could look at our y over x value, or it does cross perfectly right here. So if we look at our y and then our x, we're going to have exactly 60 per 1. So the question is, what does that represent? Well, 60 is on the y, and that's our distance in miles, and 1 is the number of hours. So that means this is a 60 miles per 1 hour, which we just write as 60 miles per hour, or 60 mph for short. And you could think about, why did I choose that point instead of any of these other points? And the main reason is I don't have to simplify because it's already a 1. So therefore, it's the quickest one to use. Okay, same graph. Now we're doing part 2b. How much time does it take the train to travel 660 miles? So once again, we can use our our graph for this. We go to miles. Here's 660. This is where you could use highlighter to show where you got the answer. You would highlight here with an arrow and then go down, and therefore it is 11 hours. Remember your units, please. 2C, how many hours would it take for the train to travel 1,380 miles? Well, this number is not on the y-axis. This is off the graph. So we have to use some information. So back on 2A, we figured out that each of these is 60 miles per hour. So after 1 hour, the train has traveled 60 miles. So if we want to figure out how long it's going to take to go 1,380 miles, we have to use our 60 miles per hour information. So it means 60 times something is 1,380. So therefore, 1,380 divided by 60 will be the answer. Because whatever we have here, divide by 60, you get this. So like here, 120 divided by 60 is 2. So 1,380 divided by 60 is 23 hours. That's our answer for that one. Please make sure you write hours and have your units. So this is for the table we're going to do, just some information. Based on this infographic here, the average American consumed 45 grams of sugar, the amount found in one of today's 12-ounce sodas every 5 days. So that was back in 1822. Didn't have a lot of sugar back then. So after 5 days had passed, they'd only had the equivalent to 1 can of soda. In 2012, the statistic is that now a person on average consumes 765 grams of sugar every 5 days. So that's equivalent to, let's see here, we've got 6, 7, 14, 15, 16, 17 cans of soda over 5 days. And that's sugar and all different things that you eat, whether it's candy or yogurt or even, milk has added sugar. So it's just showing that there's a lot more added sugar in our food nowadays. So now we're looking at example 3, top right of your notes page, where we have a table. We have a number of days and the grams of sugar consumed by the average American. So what would the constant of proportionality be? Please remember, first value in a table is X, second value is Y. We have our input and then output as the result. So we could use any of these. I tend to just use whatever numbers are the smallest or the first one. So 765 over 5. If you divide by 5, you get 153. So what is 153 representing? Well, our Y is the grams of sugar. So this is 153 grams of sugar per day on average, which is kind of crazy when you think about it. How many grams of sugar are consumed in 1 year? So if it's 153 grams of sugar per day, how many days are in an average year? Not, counting a leap year. 1 year is 365 days. So therefore, we multiply 153 times 365, and therefore the average American consumes 55,845 grams of sugar. Okay, just a little bit more information about sugar. The World Health Organization says that the recommended amount someone eats in sugar per day is 25 grams. Okay, so if we go back here, that what people are eating is 153 grams of sugar per day on average. But the World Health Organization for your health says don't eat more than 25 grams, which is equivalent to 6 teaspoons. So just to show you how easy it is to eat 6 teaspoons in a day, a 20-ounce Coke or any type of soda is equal to 16 teaspoons of sugar. So World Health Organization is recommending 6 teaspoons. One's 20-ounce soda has 16. So drinking that soda already puts you over double what the World Health Organization is recommending. Okay, we're down to example 4, which is chocolate bars. Those also have sugar, but we're looking at chocolate bars and calories. So what is the constant proportionality? Y over X. I tend to use whatever one is listed first. You could do this one. It's the smaller numbers, 606 over 3 or 808 over 4. It doesn't matter as long as you do your Y over X. They will be the same value, which is 202. And what does that represent? Well, Y is the calories. So this is 202 calories per one chocolate bar. How many candy bars need to be eaten to consume 3,030 calories? Okay, so that's not in the table. We don't have that anywhere. So in order to figure this out, we have to divide by our constant of proportionality, because 202 times something will equal 3,030. So 3,030 divided by 202 will equal 15 chocolate bars. And that is the end of the notes for today.